Hello, and welcome back to VTubing. Sent to the future from the year 2000 by a glitch due to the Millennium Bug, I'm adapting to thrive in the peculiar conditions of the 2020s. Join me in a multimedia extravaganza as we surf the World Wide Web, catch up on 2 decades of video games, and mess around with creative tools new and old. I'm Millennium Cyborg. Welcome to the new millennium. And welcome to the what was I thinking? Not trying to get too many follows too fast arc. I'm getting close to affiliate. Like, it's going to happen this year, I think. And I don't think I'm ready to, like, I'm going to be busy the next couple of months. There's Thanksgiving, there's Christmas and so on. So I'm like panicking a bit. It's all good. It's all good. Can always push the celebration stream to next year anyway. It's been a busy couple of weeks. So, I mean, we had the 6-month stream, which was something I wanted to do for a while. The costume change, the transformation, the 3D step mania. That was a lot of stuff. My wish list was far longer, you know. But we did a lot in a short amount of time. Got a lot done. And I was reflecting on how, since I started VTubing, I've actually finished and released so many things, whereas before I would just, you know, open up Blender or something, do half a tutorial, get barely anything done. It's been a great focus for my learning of new skills and finding fun little projects to do and release. And along those lines, another thing I wanted to do in October, and that I was worried I wouldn't have time for, but I did manage to do, was with the upcoming release of VTube Vroid Studio 1.0, they added the ability to create glasses, which meant that potentially a lot more people would have brand new avatars with glasses. And since I released a video on the, you know, the reflective effect I'm using here, I thought the ideal thing to do would be to let people add that effect to their avatar without having to install Unity and all the plugins and everything. Hi David, welcome to the stream. So I made this page, and let's enhance the lighting a bit here. Is that too much? I kind of like it. There we go. Millennium Cyborg's page that sets your Vroid model's glasses texture to standard shader 0.5 alpha. Is that a catchy title or what? So the way this works is you just drag your exported VRM file onto the drop zone, and it prompts you to save an output file where I modified the material for the glasses, assuming you've created glasses using Vroid Studio, to basically exploit the glitch that I'm using. Like, it's not supposed to work, but it's really cool. And then you can go straight to my video and to my my shaders and the installer for stream effects, and it would be really cool if I saw just one other person, you know, actually use this. I'd feel like I'd done something cool. So I'm hoping that will eventually happen. I've got a bit of traction on Twitter, you know, but I've not seen anyone actually use it yet. So the next arc is going to be, I mean, I don't know how long I'll do this, but Nodevember. This is a quite recent event. I think the first one was 2019. Let's see what they say. 2019. started by Blender developers and simultaneously started by Substance 3D as well. Had the same idea for a month, and November is, you know, it's NaNoWriMo, it's a bunch of different creative projects, kind of like Inktober as well. People challenge themselves to complete something. Nodevember, the idea is to create something procedural, something graphics or audio related, procedurally, following, you know, inspired by daily prompts. And this year they've doing prompts every 2 days, because every day is quite a lot, and you know, people put a lot of time into this. I saw people put 5 hours into one of their entries, and the idea is you do this and then you use the official hashtag on Twitter and so on. It's mostly intended to be node-based software, but I've been really into Shadertoy recently, and they do say Node a lot, but in one place they say, oh, it's okay if you're doing anything procedural. So that's what I'm going to do. We've got Shadertoy right here. This is not my Shadertoy project, but it's a very cool website where you can edit a shader, you know, live, and make changes and see them updated in real time. So I'm off the top of my head, let's just say I'm just going to invert the result of this thing. Does that work? No. And it gives you errors right there in the editor. And it's got a bunch of nifty features. You can do sounds with it. You can both have visuals reacting to audio, and you can generate audio. You can bring in some like various image maps and things, and tracks off SoundCloud, and then there are guides on how to port these shaders to various things like Unity and Touch Designer and all kinds of places you might want to stick a shader. Hey Barbadino, good to see you. So what was this? It's just some other tab. So I'm going to be referencing actually the website of the creator of Shadertoy, Inigo. I don't know if I'm pronouncing it right, but Inigo Quiles did some very impressive stuff in the demo scene, and created Shadertoy, and has lots of cool articles about mostly sign distance field ray marching, and then he's got his YouTube channel, and we've also got this guy, The Art of Code, has some really good videos I've been watching. Again, taking those concepts and explaining some other effects you can do with them, like this refraction, doing reflections, and so on. And really impressive stuff like this. This right here is entirely done. I mean, sound aside, the graphics here are done within one shader, one fragment shader, which is running. So the graphics card is just rendering a couple of triangles, and then inside the shader, it's doing ray marching and generating this scene based on quite a small amount of code. It's defining various shapes and blending them together, defining materials, and the animation, of course. These can be really expensive to run compared to a traditional, you know, forward or deferred rendering scene built out of polygons. But it's kind of easy to get started with, and very little code. So that's why I've been having fun looking at this. So the aim is going to be, I spent far too long working on this little thing at the bottom that blows up the URL we're using at the moment. So you can go back later if you want to look up specific Shadertoy URLs and so on. It'll be visible nicely in the VOD. Okay. So the theme, the prompt for the current couple of days, and I'm starting on day 2, is 3-sided. And my thought was my idea is a triangular prism kind of with reflection and refraction effect and some interesting environment mapping. And all of those things are going to be procedurally generated. So we'll see how far we get. So I'm going to need to start with one of these. There are a lot of articles on here. I'm gonna start with the entry point I got to the right page from. So ray marching, simple shapes, this video, and then a link to the article. Yeah. Here we go. So there we go. Triangular prism. I'm being very I'm not being very ambitious compared to what other people are doing. If you search for Nodevember and see what people are doing, they're doing really impressive stuff. But yeah, this is me going through tutorials basically and making it a stream. So Nodevember. Day 1, 2, 3 sides. And rather than type out a bunch of code, I'm actually going to go straight to one of the examples here.
Hey, welcome to the article.
Find the corresponding where'd it go? I like how on the website there's a warning on the Shadertoys that are particularly demanding. So I have a 3070 and, you know, some of these I can't run in 60 FPS full screen. I was on the right page just a few hours ago. Right. So this is not mine, but it's got a good starting point. So the idea with sign distance field ray marching is that you're doing essentially ray tracing, but instead of ray tracing into the scene and checking for intersection with a sphere or you know a mesh especially, you're going to treat the scene as some unknown function that returns to you from a point, the distance to the nearest object in the scene, or the nearest surface point in the scene. And if you query that function, you know that you can advance your ray safely by that amount, and it won't hit anything. And so you do that repeatedly until the distance to the nearest part of the scene is very small. So that will give you just the distance. Based on that, you can also get an analytic normal for the surface normal. Did I say analytic? I think it's a numeric computation of the normal. And hey Bentai, good to see you. You can do reflections by, once you've hit the surface, spawning a new ray from that surface point, and you can do lighting by, well, doing your usual sort of lighting computations based on the surface normal, the incident ray, and the the camera angle and the light and the light direction and all that. So just based on that function that gives you the distance to something in the scene, you can actually do a lot of what you'd want to do in a 3D rendered scene. It's not efficient because you're writing inside your shader, you're writing a for loop, and then lots of if statements. All of those branches are not great for shader performance. Actually, right now it's running at 144 frames per second, which is kind of a waste for this stream. I wonder if I can easily turn that off. And I'm thinking through the NVIDIA control panel right now. Okay, I don't need 144 Hertz, but I don't want to fiddle with it on stream. Okay, so what are we going to do? I'm going to copy the I should have made my own framework code to get started, but all my preparation, like my hours of preparation last night, was just getting the stupid URL bar at the bottom working the way I wanted. Yeah, let's just start with just copy the whole thing. And then we don't have a channel here. So there's an environment texture in this one that we don't have here. So let's actually do that. Let's make an environment color based on the ray direction. And ray direction as input. So we're going to have the ground color. And the ground color is going to be I'm already thinking about more complicated versions of this. Let's do a unity scene sort of gray. So 0.5, 0.5, 0.5, and then the sky color. Then we're going to do sort of sky blue. So we're going to do, I don't know if this turns out sky blue. I'm just going to try it. Kind of a cyan. that's too much. Try that. And then, so the we want some kind of value that's going to change based on the height. I'll try just the Y component. We better probably to take the angle or something, but so the ray direction Y. And we're going to use the smooth step function to give us an interpolation between, hang on. So we're going to have a parameter t. So smooth step is a polynomial that smoothly interpolates between 0 and 1. And I've been learning both HLSL and GLSL at the same time as I mess around in Shadertoy and then convert those to stream effects shaders for my stream. So I'm getting very confused in my syntax. So the ray direction is going to be a normalized vector, and the smooth step expects something from 0 to 1. So we need to divide by 2 and add, so multiply by 0.5 and add 0.5. And then there must be a built-in function that does this as well, but how are we doing? Color equals environment color. So what I'm doing is I'm replacing in the original shader, there's I think it's a cube map that it's querying, and for Nodevember we want to do everything procedurally. So I'm replacing the cube map with a function that's going to give us an environment color. And R is the reflected ray here. Interesting. Well, my sky color is fine. So if RD is the ray, I guess I've not really thought about whether this is in camera space or world space or what. So this is -1 to 1. Times 0.5, it's -0.5 to 0.5. Oh, no, I should be looking up smooth step. GLSL. Yeah, I just got it the wrong way around. Interesting. Of course, the sky is in the positive direction. Nice. I'm going to make that a bit darker for the ground. And then I kind of want to tighten it up. So I could either modify the parameter here or the bounds. So if we change the bound to say 0.25, 0.75. Even more than that. 0.4.6. We get more of a sharp transition. And then what else can we add to that? The environment look more interesting. Thinking something like if we're above 0, might turn this into another smooth step. Do like sky. Some kind of, so let's get the always get we want the RD Z RDX the beta. So this is like our in the horizontal plane, what's our view direction, and then based on that I'm gonna do some kind of sky equals sine of theta times 12 so that's, well, let's see what that looks like. It's a very picky about int versus float. So we've got kind of of course it's going negative as well. I wanna modulate that a little. Say 0.4 times. Nice. And then the ground plane is very, very boring. We add to the ground plane. There's lots of stuff I'm not getting into yet, like fractal based noise and like violin noise and all that sort of thing. I just want to add a bit of texture to it. So this time we're going to use I'm not sure. Maybe what I actually want to do is to make an actual plane or something. Let's go greater than minus 0.2. Too far? It'll give us a floating, more of an effect of floating inner space around us. And then what's the I'm just gonna try something. Let's say float right. What was it? X equals dot of RD dot. So here I'm taking the direction and then the magnitude of just the XZ component of the ray from the camera, and so we're gonna say I'm gonna leave it at full magnitude first and see the effect quite dramatically of RZ. So RZX is going to be 0 to 1 times right. Well, you know, that gives us not a bad sort of effect. Then I'm gonna modulate that a bit. I'm gonna add to that. So the radial outwards effect is nice. So now I want some very high frequency noise on top of that. So we're gonna do times, I don't know, picking. Oh wow, that's kind of freaky. And then we're going to add to that sign don't matter too much here, but times I should be picking co-prime numbers probably, just because by co-prime I mean I make up a number and it's probably co-prime, so that we don't get repeating patterns. That's very strange. So the in the outward direction, that's a bit too high frequency. So let's get roughly halve it. Interesting. And then because that's way too much, actually that one was fine. This one is too much. Not quite what I was going for. I don't want. better. All right, and then instead of a harsh transition at the border, let's have both calculations. And then return not getting very creative with the naming scheme here, but so this is going to be smooth step with rd.y minus plus 0.2. Yeah. And we're going 0 to 1. And then go T2 times sky top plus 1 minus T2 times sky bottom. Okay, and now again I want to tighten that up. So it's going to start at minus 0.2 and end at 0. That's what I wanted to achieve. Does it look any good? Not sure. I'm still not sure about that. That high frequency. Noise. I'm not that happy with. But otherwise, it's very grey. But I just add a touch of green. Too much. That's good. 3, 2, 5, 3 on the cyan side. That's something. And then the sky top thing is a bit. Oh, interesting. Bias it a bit. Don't get total darkness. You know what? That's pretty good for a start. We've been going for 44 minutes. Wow. For a start. Okay. I should explain what this code is actually doing. So, Shadertoy gives you kind of mouse input, and this is using that to define a rotation of the camera ray. The camera ray itself is determined based on the position within the viewport. So we get that as an input. As a fragment coordinate here. So that's in pixels. We convert that to UV. It's range 0 to 1. Is that right? Record minus 0.5 times resolution.xy divided by resolution.y. So based on the position in the viewport, we get a ray direction, and then we call this ray march function, and this contains the loop that says get the distance to the scene based on the sine distance function, and if the nearest object in the scene from our current ray position is, 1 unit away, then it's safe to march our ray forward by 1 unit until we're either so far out of the scene we're never coming back, or very, very close. And then this uses a vector 2 result rather than just a distance. The second component of the vector is an integer that says what material, well, a float, but it's an enum value that tells you what material we hit as well, because otherwise you don't know what sort of thing you hit. So here we've got different materials for, the spheres, the base and all that. So it's time to start getting rid of the geometry in this scene and creating our own, I think. So we've got the scene right here, and it's not like set up in the way that you'd set up like a scene in Unity or anything like that. It's a very ad hoc, kind of a creative and artistic approach to creating something, right? You're just like slapping down various primitives and then saying, okay, well, so to combine two different elements in a scene, what you do is you use the minimum. Well, as the simplest way to combine them is to use the minimum distance. So you compute the distance to one element, the distance to another element, and you say the minimum distance in the scene is the minimum of both of those. And this code has a utility function that computes the minimum for this vector2 type that also includes the material information. So I could just get rid of everything in one go. So here's the triangular prism calculation that we'll use. I'm just going to say the material is the metal that's currently being used for the balls in the Newton's cradle. Just make sure it works. So SD try prism. I've got key and H for the height of it, I suppose. Fine. Let's just see what that gives us. Oh, right, vector 2. Yeah, that's a good start. So in order to, so we've got a function that gives us the distance to a triangular prism. In order to move that prism around, we're going to transform the query that we're making on that function. So for example, I want to move it up a bit. And then I wanted to rotate, so try to think. There was a point in my life where I would sit down and, you know, really make sure like I understand where all the derivations are coming from and what space everything is operating in and so on, you know, in the mathematics. And it's a lot more fun to just do that later if necessary and just jump in and fiddle with things. So I'm going to rotate. We've got a rotation right here that was in the code, so a 2D rotation matrix, and that'll do the trick, I think. So we want to rotate by an angle that changes over time. How fast do we want it? The I time is in seconds. How about... yeah, you know what? 1 radian per second is probably about right. So what are we doing? Prism origin. Oops. I don't know what to call this position, like, is it transformed or something, but we're going to rotate this one. The so-called swizzle syntax for accessing vector elements in HLSL is very convenient for this sort of thing, so I can just say, actually I might as well inline it. So for instance, XZ would be a horizontal rotation, XY would be along the axis, right? You know what, I'm amazed that worked. So I was kind of guessing half the time about the order of operations. I guess I've been doing these a bit like off stream and I got it wrong many times, and so I'm getting lucky and getting it right a few times. I want to rotate the entire thing around which axis? YZ, and this is going to be just by a fixed amount. So 145 by, could define 2 pi somewhere, but and then by how much? 0.15. Okay, so that one needs to go before. And that's too much. Let's just remove the 2. Okay. And I want us to rotate in the XZ. And this one's going to be a very slow. 1, let's say. Sorry, I meant X. What's missing? X, Z, right? This time I'm missing something. Let's make it go much faster so I can clearly see what I'm doing. Yeah, that's what I want. It's a bit too much flashing. Oh, you know what? It's because the environment isn't rotating that it doesn't look like what I wanted. I'll do this and then over here. Alright, that's dizzying me, but that's what the effect I want. So 0.3 and paused. Nice. I'm gonna move it up a tiny bit more. I kind of want to make it refractive now, and I haven't even watched the video that explains how to do it. So this is the sort of effect that I'd like. Oh, interesting. It's even doing chromatic aberration. Do I mean chromatic aberration in this case, or do I just mean... I mean, it's basically the same effect, right? The lens that's... bending different wavelengths of light, different amounts. How much of this is dependent on... Calculate the outside hit. Where's our... Oh, right. This is outside the main March loop. Let's compare. Our materials here don't matter. Just call equals ref. I might get into materials later, but what's all this? That's the diffuse component. You can see how much I'm leaning on the tutorials by this by the art of code here, but it's lots of fun to gamma correction. Well, I suppose gamma always use some gamma correction. Oh, it's right there. So we've got an index of refraction, dmat.x versus so we replace with references here. I mean, we could remove the whole dmat thing as well. Note d equals d.x. Tags, SDF, ray marching a tag, ray marching, node, and I don't know what happens actually if I make it public. Can I still edit it? Make it private for the moment. I'll make it public. What happened? Oh, because it reloaded and I'm editing things. I don't know what happens if I make it public and then keep editing. What did I do there? There we go. Alright, so we've got 3D hit addition. The same. So we're replacing the environment by this. Then trying to see if there's anything else we need to worry about. Reflection texture. RD out. Also, we'll just say This is a bit funny, the code, because we're kind of reusing quality out 3 times. Anyway, we can just say get env quality out env call, I called it. Remarch. So Remarch has an extra parameter here. Side. So we're now using the same ray marching inside the object as well as outside it. One more of these. This feels like cheating, really. Looks cool. I mean, this is what I had in mind. I sort of understand the code. What should we add? One thing I've always wanted to try is, how do we do this? So it's one nice thing about the sign distance field approach is that it's very easy to make multiple copies of something by repeating it. Because it's just a function, you can make it repeat. So we can say this is right. You're not right. Whoa. Almost right. That's... Huh. Like the it's being distorted in ways I don't fully understand. It must be on this page somewhere. Infinite repetition. Are function pointers... Do you have function references or pointers in HLSL? I would have thought not. Maybe this is just pseudocode. Yeah. There we go. So you can see interesting effects here actually at the edges of some of these where the number of... Like we're not going quite far enough with the number of steps in the loop here. Nope, not that loop. The ray matching loop. There. And so it's causing these strange effects. So if we... Actually, we can look at a very small number of steps. That's... You know what? That looks very cool. Flashbacks to Amiga graphics demos. Yeah, that's... That does tie in because the guy who made Shadertoy and whose website I'm referencing was in the demo scene. I mean, still is, but I think was most well known for demo scene demos around 2004. So there with the higher step count, we've got something much smoother. Hi Ren. Yep, Nodevember. Although, like, my argument is the website for Nodevember says anything procedural counts, and so I'm doing it in Shadertoy instead of Blender or Houdini or all of those things. And I'm mostly copy pasting, but from a couple of different places and tutorials, but I've achieved sort of the effect that I wanted. The environment is a bit funky. I was... What would I want for the environment? Like, really, I'd want to do some clouds and things, but I haven't thought that far ahead. How are we doing for time? I mean, I'm not doing too bad for once. I actually ate before the stream, so I'm gonna add something. Let's bring the prisms closer together. Oh wow. Oh wow. So you still don't see the prisms through each other. So after it does the primary ray, so we're doing a refraction to the exit point, and then at that point it's going straight out to the environment, right? So instead of that, we could add further child rays. But I'm too tired to think about how to add that at this point properly. You know, that's a bit too many prisms, I think. I'm getting dizzy. I'm gonna slow it down and make it fewer repetitions. Something like 7. And then how about some kind of disturbance? E dot y plus equals sine of E dot z time 0.1. Um, 10 times. Yeah, that's gonna be too much. E dot y dot x. But no, is that not very obvious? Trying to get kind of a distortion effect across the whole scene, but I'm not thinking about it very clearly. Like which one is our main axis here? There we go. You know, I think I quite like the yeah, I like the clean look with straight edges. But maybe coming across the entire... Where was I changing it? I was changing it after the mod. So if I do it before, and then do it like this, modify Z based on XY. Based on that's not going to be right. I need a square root in there if I want. Let's see what happens. Okay. That's very cool, but not what I wanted. I'm imagining. Oh yeah, you can kind of see it in the background, right? An effect that distorts the entire field of them out in the distance. Maybe what I actually want is... Oh wow. The ones in the background turn to complete noise. So I don't want that. Or if I did, I'd want it after the mod. That would apply the same to all of them. Yeah, it does. But what I want is... I want something much smaller, right? So like 0.02. I don't want this because it increases square root. And then I want the magnitude to be much larger. Opposite direction. That's starting to get at what I wanted. Minus 0.5. Interesting. Not sure I'm getting much effect out of the sign there, right? Okay, it does have an effect. What do I actually want? I want to see some large scale deformation. All right. And then, so that's an XY lane thing. So it looks good from some angles, not others. I could just combine multiple rotations. And then I don't know why, I don't know these particular choices of axes. ZY based on X, XY based Z, then Z based on. I've got ZY and YZ. Z. Z, X, Y, Z. I've been saying them too many times and getting confused. And then like 1.1. I'm just picking like something. What don't we like here? Comma. Whoa. I'm doing something very weird. I mean, these preserve. I don't know. I'm probably doing this transformation in the wrong domain somehow. It's doing something funky. I want to avoid the areas where it looks really stretched out. My mouth goes funny when I'm putting my hand in front of my face and then the camera thinks I have my mouth open. Looks a bit weird. Instead of this, what do I want? I kind of want the position to the further out you get from the origin to kind of twist by some amount, right? I'm trying to do so we've got a rotation of, or maybe it should be the same. So in XZ, based on the XZ distance, then where do I have this? That's the component based on this one's just the distance, and that's the amount of radians per unit distance. That's very cool. This is a lot more like what I wanted. Yeah. A bit more, a bit less. A bit less. Somehow it made me ill to look at. I finally got what I wanted and it made me ill to look at. This is better. All right. I'm going to fiddle with the environment again before I call it done. So the environment, I'm going to go back to, so it's easier to see. What was it? Max dist. And then whatever. So now we've just got the environment. I want something like I don't know, ideally I'd say clouds. I want something like Berlin noise. You can see that these techniques can do far more impressive things than what I'm doing right now. So what do we have here? Let's have 3 octaves of noise. What do we have? H and X. This is going to be a vector 2. And H is just... Does that exist? To the X, right.
Hey, welcome to Year of Code.
Oops. So what's it calling it here? FBM. Fractional Brownian motion. Where does it get the noise from? Random. You can see the highly scientific process I'm using. Copy pasting stuff. Seeing if it works. So we've got our noise. And we're going to make this 1D noise in this case, right? Noise F times X. F is float, X is a vector 2. Okay, so it's 2D noise. So I'm thinking we're going to pick a value for H. H equals 1 seems fine. And then this 2D vector is going to be our angle, our theta and phi. So that's going to be a tan of RD dot. I've got theta, vector 2, theta phi. And phi. E. What's going to be Y. Is it YX or YZ? It'll be one of those. Is that good enough? Vector 2. Load. That should be vector 2. My brain is not working anymore. And that's very, very noisy. So that's, we've got some... Where was my noise? So if I say I want 3 octaves, are the successive octaves larger or smaller? F times equals 2. If I say 1, if I say 10, I guess successive ones are larger. I want the starting to be larger, like 4. Is that good? Can't tell. 16. And A times equals G, so A starts as... Now... G, comma, 16. No, 4. We're skipping iterations. Nice. So let's say float skip equals 8, and then we get times 2 times 2. No, it's actually power 2 skip. Skip. Skip 4. Okay. If we compare that to removing it completely, okay, not much of an effect. It was giving more of a like film noise grain to it rather than so let's say like, oh, you know what, let's visualize it directly. Yeah, the amplitude isn't huge. Or no, it's just too much. I might be, let's see, self-similarity. Let's drop it to 0.5. I want some variation across the scale of the entire image. You know what, I'll subtract the noise since it seems to stay positive. That's very noisy. Let's multiply the input. Did that help? I mean, I guess the trouble with working with a self-similar kind of fractal thing is that it's noisy at every scale, but I'm expecting to hit a limit to that. Oh, neat. So, I mean, really we're seeing our noise function, you know, based on signs and things, rather than seeing the real effect of the fractal Brownian motion here. Well, it's too late to think about this. I'm confusing myself. Let's go back to the version that worked. So I don't know if I'm going to do this every 2 days, like in the you know, the Nodevember thing, but it's at least a good inspiration for prompts to do every 2 days. And let's make this public. If anyone wants to have a look after this, write it themselves, figure out what I couldn't figure out with the noise, adding the noise to the background. Awesome. I should put myself back in the middle. Okay. Yeah, so I hit so many of my my targets and my list of things I wanted to do that I don't really have a plan for this month, apart from messing around with shaders. I still have lots of games in progress I've been enjoying. I want to go back to Project Wingman and probably Hot Wheels. And what else? Yeah, with Viroid Studio coming out, the obvious thing to do is for me to get myself a new base mesh based on the new Viroid Studio base mesh. I'll wait for the HANA tools for Unity to be updated before then, so that I can do blend shapes and everything at the same time, iPhone blend shapes and all that, and that'll mean potentially redoing my weights on my various outfits, and after that I'd want to do a VSF avatar to take full advantage of like make it easier to swap between outfits without having to define a huge number of material blend shapes in Unity. I'm assuming, I actually haven't looked into it. I think I can just use animations at that point to hide things, but that I've not dug deep enough to confirm that. But I've seen people do many outfits on one VSF avatar, so I know it can be done. What else? Housekeeping. There's probably stuff I forgot, but I am going to send you over to Neff, who is streaming The Good Life. Seems like a pretty interesting game. Yeah, thanks for watching. There we go. I remembered for once to set up the raid, and it's time for me to go. And if you, like me, have caught the Millennium Bug, make sure to watch the next stream, or find me elsewhere on the World Wide Web by clicking on the links below the video. I've been Millennium Cyborg, keep that future vibe, and I'll see you in the world of tomorrow.